Imagine I have a beautiful tree that's filled with oranges. And I ask myself, what is the orange made of? How do I answer that question? Well, I want to look deeply inside the orange, so I magnify it. And I magnify it again, and if I keep on doing it, deep inside, sooner or later I begin to see molecules come into view. But molecules are not the end of the story, because the molecules, I can enlarge them. And if I make them big enough deep inside, I begin to see atoms. Atoms are not the end of the story too, because we have electrons zooming around the nucleus, deep inside, mostly empty space in the atom, but deep inside we see the nucleus. So if I grab that and magnify it, I see that the nucleus is itself made of particles, neutrons and protons. And if I grab one of the neutrons and magnify it, I find yet further particles, little tiny quarks inside. Now that is where the conventional ideas stop. String theory comes along and suggests that inside these particles there is something else. So if I take a little quark and I magnify it, conventional idea says there's nothing inside, but string theory says I'll find a little tiny filament, a little filament of energy, a little string-like filament. And just like the string on a violin, I pluck it and it vibrates, creates a little musical note that I can hear. The little strings in string theory, when they vibrate, they don't produce musical notes, they produce the particles themselves. So a quark is nothing but a string vibrating in one pattern. An electron is nothing but a string vibrating in a different pattern. A neutrino, nothing but a string vibrating in a different pattern still. So if I take all of this back together, I have my ordinary orange, and if these ideas are right, they are speculative, but if they are right, deep inside the orange or any other piece of matter, there's nothing but a dancing, vibrating cosmic symphony of strings. That's the basic idea of string theory.
Right now, string theory is the most viable contender for the theory of everything.
What is physics? Physics is nothing but the laws of harmony that you can write on vibrating strings. What is chemistry? Chemistry is nothing but the melodies you can play on interacting vibrating strings. What is the universe? The universe is a symphony of vibrating strings. And then what is the mind of God that Albert Einstein eloquently wrote about for the last 30 years of his life? We now, for the first time in history, have a candidate for the mind of God. It is cosmic music resonating through 11-dimensional hyperspace.
According to string theory, the Big Bang did not begin with a firecracker that threw the masses into deep space. The splitting or joining of two or more universes is how it is stated. The inception of the universe concept has been attributed to the string theory's 11-dimensional hyperspace calculations. There are multiple universes as opposed to one single universe made merely of time and space. If one universe splits apart, two or more daughter universes result, which if united would create a larger combined universe. This notion is, however, taken out of context when it is said in the current textbook that the universe is everything and the time and space exist in it. Just the head scratcher that is. However, others have taken this idea a step further by questioning what the universe of others might look like if it existed. This has generated many conclusions. We must comprehend how our universe seems to us to respond to that. Let's then apply this idea to multiple universes. The hydrogen and helium found are the same all around the observable universe, which is 43 billion light years away, or 96 billion light years away, with the Earth as the center of the observation. Hydrogen found on Earth has the same spectral lines as hydrogen found billions of light years distant. At the same temperature, the properties of electrons observed in the Sun are the same on Earth. Every subatomic particle has the same charge. Therefore, the universe is the same for our purposes of observation, whether it was created by design or by chance. Constants like Planck constant, the gravitational constants, and the speed of light are constants that apply everywhere. Therefore, the notions would be same if intelligent aliens from billions of light years distant from us were to create a universal equation. The fundamental units are the same everywhere. Therefore, the law would provide the same maths and understanding. Either yes or no, this idea can be extended to multiverses. It relies on the crucial stage of universe development. The underlying query is whether the parameters are randomly generated or tightly tuned to the point of formation. If the universe were perfectly tuned, it would produce a universe exactly like ours. Thus, everything may be the same. As a result, the fundamental rules would still apply in different universes. But what if things work out differently? Then, even minute parameters would produce a universe that is entirely different from ours. The fundamental forces, constants, and amounts of dark energy and dark matter in the universe may differ from those in our own. Therefore, the answer will rely on how the universe was endowed at the time of creation with intrinsic characteristics. Knowing that the laws would either be distinct from our universe or the same, life would be clear. The biological evolution would have contributed in adapting the law, and it would look entirely different.